All right, welcome, welcome. This is 8.5, Properties of Special Parallelograms. The three parallelograms that we're going to talk about today are rhombus, square, and rectangle. And so we're going to get into that a little bit right now. Before we dive into the specifics behind rectangle, rhombus, and square, I'm going to bring your attention back to the 8.3 notes when we talked about parallelograms. These are all parallelograms, so they're going to have their own features plus everything we know about a parallelogram. So, navigating back to our notes here, we know some things. We know a parallelogram is a quadrilateral with opposite sides parallel. So, fact one, opposite sides are parallel. We know that opposite sides are congruent. That's fact two. Fact three is opposite angles are congruent. Fact four is consecutive angles are supplementary. And then five, the diagonals bisect each other. I'm going to snag this. Bring it over here to our notes in case we want to refer to it. All right, I'm just going to leave that there. Okay, so in a rectangle has some additional things that make it special. So one of the things that makes a rectangle special is we have 4 90-degree angles. So I have a 90-degree angle here, 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 and here. Right? That means that consecutive sides are perpendicular. I'm going to go ahead and I'm going to give this rectangle letters on its vertices. You can pick other letters if you want to. I'm just going to use A, B, C, and D. So first point is that I have 4 90-degree angles, and then I have diagonals that are congruent. So I'm going to draw in my diagonal AC. If you're doing yours on paper, hopefully yours are a little straighter than mine. You can use a straight edge like a ruler or the side of a card. And now I can say that diagonal AC is congruent to diagonal BD. This means they have the same length. So those are in addition to, right, if I kind of draw your attention back over here, parallelogram where I have opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Okay. What makes a rhombus special? So rhombus is probably the more obscure shape. A rhombus is a parallelogram that has 4 congruent sides. So all the sides are the same. Almost like a square, but I do not have 90-degree angles necessarily here. I'm going to give this some other letters here. E, F, G, H. So I've got 4 congruent sides. If you think of this as like, if you were to nail 4 pieces of wood together on their ends and make a square, if you kind of like put some pressure on that, it would slant a little bit, and that's what a rhombus is like. All right, so I have perpendicular diagonals, so I'm going to draw some diagonals in here. These diagonals make a 90-degree angle. So if I write that in words, that's EG is perpendicular to FH. So this upside down T is perpendicular to. Should be a nice box in there. And we also have that the diagonals bisect the corner angles. Going back to what we know about parallelograms, this green fact right here, opposite angles are congruent, which means that this big angle F, right, the whole thing, is congruent to the whole angle H. But now I've got that the diagonals bisect the corner angles. So this piece is going to be the same as this. This piece is going to be the same as this. Similarly for when I'm at vertex G, also bisected. And now a square has all the properties of a rectangle and all the properties of a rhombus. It's also a parallelogram, so it has those innately. All right, so if I call this, let's say, don't mind the bell. So if I call this JKLM, things that we know that all of the angles are right angles. We can draw in the diagonals. Ooh, those are not my best work. I know that the diagonals are perpendicular. I also know that the diagonals are congruent. So KM is congruent to JL. They are perpendicular. KM is perpendicular to JL. These diagonals will bisect these angles. And since all the angles are the same, I actually get 8 congruent little angles in here. We know that all the sides are equal. Oh, we know so many things. In addition, we know consecutive angles are supplementary, the diagonals bisect each other, and opposite sides are parallel. So much. The first example would be easier if they told you what kind of parallelogram it was. But it's not given. So we have to use a little bit of our sleuthing skills to figure it out. Example 1, find the values of the variables in the parallelogram when the measurement of angle 1 is equal to 5y plus 15. And on the picture there, you'll see a 5x degrees and a 2z degrees in the corners. And we're going to go ahead and break this down. So first thing first, I can notice that this right angle at the very top, right, that gives me either a rectangle or a square. Now I do have these consecutive sides that are congruent, and that's true for a rhombus or a square. So then, since I have the right angle and these two sides are congruent, then that means that this is a square. So I've got these angles to find. I'm going to start with measurement of angle 1. What do I know about these diagonals? Well, in a square, the diagonals are perpendicular. So this creates a 90-degree angle. Actually, it creates 4 90-degree angles, right? I've got 90, 90, 90, and 90. So when I rewrite what's given to me, measurement of angle 1 is equal to 5y plus 15. Oh, what is the measurement of angle 1? Oh, we just said that has to be 90. And then I solve. So to get y by itself, I'm going to subtract 15 from both sides first. 90 minus 15 is 75. To get y by itself, I divide by 5. Whatever I do to one side, I must do to the other. So we get an answer for variable y of y equals 15. So now to go back and find x and z. All right, so other things I know about a square is all of the angles are 90 degrees. Those corner angles. We also talked about how this angle here gets bisected. So if this angle is 90 degrees, the bisected angle then is going to give me half, right? Let me rewrite that. Like half of 90 degrees, and that's going to give me 45 degrees. So I can take 5x, set it equal to 45. I can also take 2z and set it equal to 45 because those are going to be the same also. And then solve. And the first one where I have an x, to get x by itself, I have to divide by 5. 45 divided by 5 is 9. Ooh, that doesn't look like a 9. 9. On the right-hand side, 2 times z, so I divide by 2. 45 divided by 2 is going to give me a decimal, and that's okay. Let's just let the decimal be there. This will give me 22.5. Sometimes when we get decimals, we want to like double check our work, right? Like, is that wrong? Am I allowed to get a decimal? Decimals are fine. In fact, you're going to get decimals multiple times in this lesson. Great. Example 2, for the rhombus WXYZ, what is WY? Now we're going to have to use a skill from that we went over in topic 9 and also that you've gone over in previous math classes called the Pythagorean theorem. So let's get after it here and take a look. I've got a rhombus. In a rhombus, I know some things. I know that all of the sides are congruent, right? So all of these are 5. I know that the diagonals bisect each other. And I know that they are perpendicular. My goal is to find WY. This is what I'm looking for. But I don't have, using my cursor, I don't have this piece of the information. So what I'm going to do, I'm going to hone in on this triangle here. And the Pythagorean theorem tells us that if I know any 2 sides in a right triangle, I could find the other third side. So I'm looking for this little side down here. This. And this equation, the Pythagorean theorem, is a squared plus b squared equals c squared. And it works for any right triangle when A and B are legs and C is a hypotenuse. So when I use it for this instance, first thing I want you to be really aware of is C has to be the hypotenuse. So check out this triangle. I go across from the right angle, that's the hypotenuse. So my hypotenuse is going to be 5. Now for A and B, the legs, they're interchangeable. So I can do 3 for A or I can do X for A. It doesn't matter. It does matter that the 5 goes into the C spot. And I simplify and solve. 3 squared, remember squaring something means I have 3 times 3, so it's 9. X squared is X times X. And then I have 5 times 5, which gives me 25. To get X squared by itself, subtract the 9. 25 minus 9 gives me 16. Take the square root of both sides to get X by itself. So the inverse of squaring something is taking the square root. When I take the square root of both sides, I get 2 answers. I get positive and negative 4. Now I need to bring that back to the context of the problem. I can't have a negative length of 4. This means that X is only going to be the positive value. That's what happens when I apply it to a real situation where I have an actual triangle here. So back to what I'm looking for WX. I now know that this piece here is 4, which means the other piece is 4. So WY, I'm sorry, I think I said WX. I'm looking for WY. WY is equal to 4 plus 4. The whole thing is 8. We aren't provided any units, so we'll just leave the units off. We will be using the Pythagorean theorem throughout this section, so if that was too much too fast, you might want to stop this, pause this video, and maybe go watch a reminder video. Example 3. For the rhombus, what is the measurement of angle RPS? When I'm looking at 3 letters in a angle, the middle letter is the vertex. So when I trace R, P, S, I'm talking about the vertex at P. I'm talking about this angle here. And if it helps for you to get a marker or highlighter and highlight that, make it very clear, please do so. Don't find the wrong angle here. Okay, we know that this figure is a rhombus. And in a rhombus, I've got 4 congruent sides, that's great. I know that the diagonal bisects the corner angles, that's great. I can use that piece of information here. A rhombus is a parallelogram, so I also know that consecutive angles are supplementary. That means that I can find this large angle by subtracting from 180. So let's call the large angle QPS. So take a look at that. QPS, so the big angle up here at the top, is going to be equal to 180 minus 70. So the whole angle is 110. And I know the angle is bisected. So if it bisects it, then that means that I want half. So this angle here, RPS, is going to be 55 degrees. And actually, just by knowing this one angle 70 degrees, I can find every angle in this picture. It's enough information. Example 4. Quadrilateral GHJK is a rhombus. What is GH? All right, things I know about a rhombus. I know all 4 sides are congruent. I know these intersect at a 90-degree angle. I know some other things. Let's see if anything else is going to help me out here. So recognize that 2x plus 3 is this piece of the diagonal. 4x minus 7 is this piece of the diagonal. And then this side is 3x plus 1. I'm looking for GH. Hopefully you can agree that if I can find 3x plus 1, HJ, then I found GH because they're the same. All right. I don't have enough information to start there, though. Let's assess what else we know. I have these 2 pieces of this diagonal. And in a rhombus, diagonals bisect each other. So I know this piece is the same as this piece. So 2x plus 3 is equal to 4x minus 7. And I can solve. Three plus 7 is 10. 2x. 10 is equal to 2x, so I divide by 2, I divide by 2. I get x is equal to 5. Now that I know x, I could plug x in to find the length of the diagonal. I could also plug x in to find the length of this outside, and that's where I want to go with this. So I know I'm given that HJ is 3x plus 1. Now I know what x is. When I plug it in and simplify, I get 16. Well, HJ is equal to GH. So therefore, I know GH is also 16. All right, if you need a break, take a break. Moving right along. Example 5, find the value of the variable in the parallelogram. So again, they tell us it's a parallelogram. They don't tell us what kind of parallelogram. We have to use the information in the picture to make that judgment. They tell me that AE is 2x plus 7, and BD, the whole diagonal, is 5x minus 4. I'm going to rewrite that. I don't like the way that turned out. Let's try this way. That whole diagonal here. All right, we have a parallelogram with right angles. So if I have a right angle here, that means I automatically have a right angle here, here, and here. From that information, I can tell that this is either a rectangle or a square. It might be a square. It doesn't look like one, but it could be. I don't have any information on the contrary. Things I know about rectangles and squares and rhombus, any parallelogram, is that the diagonals get bisected. But for rectangles and squares specifically, the diagonals are equal. So AC is equal to BD. Now I know what BD is. I know BD is 5x minus 4. And I have AE. I don't have AC. But all I need to do there is double it. Because if this AE is 2x plus 7, then that means EC is 2x plus 7 also. So I have 2x plus 7 plus 2x plus 7, or I just multiply by 2, is equal to 5x minus 4. The setup sometimes is the hardest part, guys, so just take a look, make sure that makes sense. Then we solve. 2 times 2x is 4x. 2 times 7 is 14. And when I go about solving this, I'm going to subtract 4x from both sides. And subtract 4 from both sides. Which leaves me with x is equal to 10. I always like writing my variable first. Go back and reassess. Did I answer the question? The question said find the value of the variable. So yes, actually I did. X is equal to 10. Didn't ask me to plug it back in or anything else. Example 6, find the following angles. Ooh, there's a lot of letters there. All right, slow down. What do I got? The first angle is BAM. Oof. M. So remember the middle letter is the vertex. So we're talking about this angle here. Okay. This figure doesn't tell me that it's a rectangle, but I can tell it is. We know it's a parallelogram and I have a 90-degree angle. All right. Now in a rectangle, it's not true. The diagonals do not bisect this angle, so I can't just take half. What I do know in a rectangle is that this piece right here, the angle that I've just marked, is actually congruent to this piece here. So I can approach this in a couple of different ways. I can look at this triangle, this small triangle here on the right, or I could look at the large triangle here and get the same answer. But these two angles right here are going to be the same. So if this angle is 62, then the measurement of BAM is 62. Here's another way to look at it. If I draw this large triangle, oops, 62. I know this is 90. I could find this missing triangle and work out from there. Okay. So let's go on to the next one. Let's outline MBA. MBA. So B is the vertex angle. B is the vertex, so I'm talking about this angle here. Well, going back to the triangle I just drew would be very helpful to find this angle. There's more than one way to do this. I could do this a few different ways. Okay, I'm just going to show you this one. If you did it a different way, that's totally cool. So when I focus on this big triangle, I have 62, I have 90, and then I want to find this angle right here. So 90 and 62 gives me 152. I know every triangle has 180 degrees. That gives me 28. LOB, I'm going to use another color. So now I'm looking for this angle on the inside of the triangle. Please don't tell me it's 90 because it's not. In a rectangle, this is not 90 degrees. So there's a couple different ways to solve this. You can find it your own way. That's totally cool. I know that I have 62 and 62. So I can find this center angle here by using what I know about a triangle. So 62 plus 62 gives me 124. Subtract that from 180 and I get 56. Now, it's not expected that you can watch this video once time at full speed all the way through without pausing and understand all of this. So please make sure that you're pausing this, taking the breaks that you need, rewinding, rewatching things. It'll take you a little bit longer than what the video is scheduled to be. These two angles here are what's called vertical angles. Throwback to a previous topic. And they are congruent. Again, there's probably 4 different ways you could find that angle. So if you do it a different way and it's mathematically sound, then awesome. Okay, example 7. Find the length of XZ for the parallelogram WXYZ. So XZ is going to be this entire length. So I'm looking for this diagonal. And this picture gives me absolutely no information about diagonals. All right, there's no lengths on here. There's nothing, I don't have anything. But let's talk about the fact that this is a parallelogram with a right angle. So this is actually, it's a rectangle. If all I know is a parallelogram with a right angle, then it's a rectangle. Which means I know that opposite sides are congruent. And I have 4 right angles. Now I'm still looking for this diagonal. Gotta find something that I can use. If I focus in on this triangle that you have traced in green, I have 2 different greens going on here, but it's good. Okay, so I've got this triangle kind of traced in green, like this. I'm looking for this side. I have 12 and I have 8. All right, well, that is exactly what we use the Pythagorean theorem for. So I'm going to use the Pythagorean theorem here again. Now, this one's not going to be a whole number, all right? And something that it doesn't say in here, but that I wrote on the notes is that any of your answers you're going to either leave as whole numbers or as decimals, not in radical form. So as I work through this, let's see, what goes in for the hypotenuse? The hypotenuse is across from the right angle, so it's what I'm looking for. I'm just going to leave it as C. Cool, we'll just leave C. And then I'll plug 8 and 12 in for A and B. It's okay if you swap them, doesn't matter. 8 squared is 8 times 8, gives me 64. 12 squared is 12 times 12, it's 144. 64 plus 144, 208. Now I take the square root of the left side and square root of the right side. When we did Pythagorean theorem in topic 9, we practiced taking this square root of 208 and making a factor tree and leaving it in radical form. Today I want your answer as a decimal. So instead of doing that by hand, all you need to do is pull up a calculator and ask it to calculate the square root of 208. So maybe pause this video, pull out a calculator, make sure you know how to take the square root of 208. It's critical. When I plug it in, I get 14.422. And I'm just going to round to one decimal place here. So 14.4. Going back to my original problem, I was asked to find xz, and that's exactly what I did find. Now, I called it c, but that's arbitrary, so I want to go back and call it xc because that's what it asked for, and I get 14.4. Now, in your homework, they could ask you to round to whatever decimal they want. We're just going to leave answers here to the nearest tenth, but pay attention to questions and make sure that they don't change that on you. Example 8. Find the length of KM and the perimeter of triangle JKL. So this is a two-part problem. What do we have? Take a look at that and try to determine whether you think that's a rectangle, a rhombus, or a square. So strangely, if you said any of those things, you would be right. It's actually all of these things, which is most specifically means that it's a square. But a square is also a rectangle and also a rhombus. So not trying to be tricky, just trying to inform. So I have 18 on all of these sides. I'm looking for KM. KM. We know that all of these are right angles if one of them is. So if you focus in kind of on this half of the square, right, where I have N, K, and M, I have this side is 18 and this side is 18, and I want to know what is this hypotenuse. So I'm actually going to do the same process as above. Please pause this video and work out the length of KM on your own. Okay, practice the Pythagorean theorem. We just did it in example 7, so you've got a perfect example there. They're mirror images. They're very, very similar, all right? So try to use what we did there in example 8. Please pause this video. All right, hopefully you left your variable as C, or you could put an X here or something else, but you plugged in 18 for A and B. When I square 18, I get 324. Pretty big number. 324 and 324 is 648. Oh, I am so grateful we don't need to do the factor tree for that big number. Instead, I'm going to take the square root of both sides. And when I do that, I get positive and negative 25.4558. Bunch of decimals. I don't want a whole bunch of decimals. just going to round to 1 decimal. My answer here is km. So km is going to be the length of, I only want the positive value, right? I can only have a positive length. If I round to 1 decimal place, that's going to round the 4 up to a 5. That answers one of my questions. Now to work on the other one. So triangle JKL, I'm going to trace that. I'm going to kind of trace it. I'm going to try to trace it. JKL. I have this top triangle here. Perimeter just means I want to add up all the sides. Well, good. I have got 18, and I need the other 2 sides. Well, check this out. JK is just going to be half of the whole thing, right? And I just said that this whole length was 25.5. So JK is equal to half of KM. So if I take half of 25.4558, I get 12.7. And it depends on how you round this, because if I take half of 25.5, then I get 12.8. So just be really aware of your rounding. I like to leave the full number in the calculator before I round. So this is 7279. 12.7279. So then when I take and I add those up, let's see, I've got KL plus L, JL plus JK, right? Should be the perimeter. 18 plus 12.7279 plus 12.7279. That's the sound you're hearing is me punching me in that calculator. Maybe you can hear it, maybe you can't. And that gives me a perimeter of 43.4558. When I round, I'm going to get 43.5. Hopefully you're really close in that ballpark. Perimeter is 43.5. All right, guys. And that will finish us up. I hope that you feel confident in the properties that you've learned about squares, rhombuses, and rectangles. And yeah, all right. Thanks so much. Take care.